continuous webinars for our those staff which are not registered with the as a student with the Center of Excellence. So anybody can join these webinars and they can freshen their knowledge, they can improve their knowledge. Luckily, we have expertise available within the center of some modeling tools, and our alumni are also well equipped. I am proud of my alumni and faculty. They are working efficiently in different part of Pakistan. And I am happy to introduce that Dr. Ashraf, who is one of the co-speaker of this webinar. He is a graduate from Center of Excellence in Water Resources. So is the other our speaker, Dr. Mudassir. Why we have selected this topic of hydrological modeling of snow-fed catchment. The reason is the need. Need is the mother of invention. So is the need we have seen in the last few years. More and more harnessing of the hydropower in the upper reaches of the Indus Basin have been seen, and many of those catchment which we are entering into for hydropower and for diversion of water. So more and more those watershed are ungauged watersheds, ungauged basins. So traditional statistical methods of hydrological estimation, water availability estimation, those are not available when we don't have the data available to them. So in such cases, these distributed physical based models which rely on the physics of the phenomena, so those are more reliable. And hopefully today's webinar you will be learning one of the state of the art tool of modeling those catchment which are covered with the snow. Majority of the catchment, if it is covered with the snow, so normal rainfall runoff model will not work over there, because rain immediately is converted into the runoff, while snow takes some time to be converted into the runoff and comes to the channel. So this thing has been taken care by specialized model. One of those models, I hope my colleagues will be teaching in today's webinar. So we show our commitment and our pledge that we will continue to fulfill our duty to disseminate the knowledge, to train the researchers and the engineers in as best manner as possible. We need your help and your support and your patronage in this regard, so that we can improve this way of dissemination of the knowledge. If you have any comments, if you have any suggestions, our channels of communication, email, WhatsApp, those are open. You can personally visit my office. You can personally visit my colleagues. They are open. Over the last few years, we have tried to improve the facilities in the Center of Excellence in Water Resources. We are improving our lab facilities. Even yesterday, there was a meeting of the purchase committee, and we are trying to acquire more lab equipments, more modern computers, and more facilities for students and researchers. We are trying to modernize or improve our physical modeling facility also in the MT hall. We have improved our GIS lab with the state-of-the-art computers. We are trying to bring more computers to the computer lab also. So also we will be trying to improve our equipments, major equipments in our water quality and in our hydraulics lab also. And on the other side, we are improving our human resources facility, so that we can better serve the students and the water related community. So I will not take much time. You should be not much away from your main teachers, so that they can start it. So once again, this arrangement of webinar is not a simple job. It takes a lot of efforts. I congratulate Dr. Mudassar and his team, and I am thankful to Dr. Ashraf for sparing time for this webinar. My message to the participant will be, please try to gain as much as possible, and my message to the speaker will be, try to make it as much interactive as possible. Both way communication should be kept open, and try to engage the participant in the webinar. It should be a part of it should be the theoretical knowledge, and part of it should be hands-on training kind of thing. Hopefully, this seminar will be beneficial for all of us, and we will be delivering it in a better way next time with a demanding title of the webinar. Also, I would like to mention that we have planning for a conference in the coming months, maybe in next year. So we announce sooner. Thank you very much, Mudassar and Ijaz and Dr. Ashraf, and over to you. Who is coordinating, Mudassar or Ijaz?
Sir, I am coordinating it.
Okay. So I am switching mute to mute.
Okay. We have more than 32 participants have registered for this webinar from 15 different organizations, including from Canada, China, and Turkey. And I think now 29 participants have joined the meeting, and we can start without any delay. And now I invite Dr. Muhammad Ashraf to deliver his lecture on remote sensing data processing using R package for hydrological modeling. Dr. Muhammad Ashraf is working as an assistant professor at Khwaja Farid University of Engineering and Information Technology, Rahim Khan, and he has a vast experience of hydrological and flood modeling. And previously, he has also worked in WAPDA, Glacier Monitoring Research Center, and he has experience of simulating and the glacier melt processes. Now I invite Dr. to start, please. Dr. Muhammad Ashraf.
Bismillahirrahmanirrahim. Thank you, Dr. Ijaz, and I'm very thankful to Dr. Noor Muhammad Khan and Dr. Mudassir Iqbal to invite me for this session. And I have prepared a presentation on the topic, and Dr. Noor Muhammad Khan made it easy for me because I have just added a few slides to introduce about the modeling of studies. I just want to share the presentation with you. As Dr. Ijaz introduced, I am currently working in the university, Khwaja Farid University of Engineering and IT, Rahim Khan, in the Department of Agricultural Engineering. I joined this university in 2019, and I selected this topic when Dr. Mudassir asked me that what should be the topic. Then I decided that I should disseminate about the processing using the R package, because I have done some work during my tenure at WAPDA during 2015 to 2017, and NESPAC has developed basically a hydrological model, and they developed a procedure to process the remote sensing data using the R package. And I want this that all other participants of this session should learn about this package, that how this package functions and how remote sensing data can be processed using the R package. Initially, these are the contents for this presentation. I have added the introduction about hydrological models, and then the steps regarding this normal runoff modeling and the application of R language in hydrology, and then the installation of R package and its graphical user interface, and added some guidelines for the initial user. And at the end, I have added many slides to show you that how remote sensing data can be processed using the R package. Hydrological models, but basically, the purpose of hydrological model is to simulate and forecast the runoff from the catchment. This is the basic purpose. And you know that in our Pakistan, only a few organizations are using these hydrological models. However, many researchers have used the runoff models, hydrological models, to simulate the runoff from the catchments. Uh, However, in WAPDA, I was working in GMRC Glacier Monitoring and Research Center, and they were using initially they were using the UBC watershed model, and then they also have facility to simulate and forecast the runoff for the catchment of Mangla using the SRM model. Uh, Therefore, the basic purpose of hydrological model is to simulate and forecast the runoff from the catchment. And plus, there are many models. Some are Dr. Noor Muhammad Khan Sahab said, there some are rainfall runoff models. Similarly, some are snow melt runoff models, and some are the glacial melt runoff models. Rainfall runoff models have only capability to simulate the rainfall only. Like previously, HMS has the capability to simulate the rainfall only. And GR4J1 is also an example of the rainfall runoff model. And the snowmelt GR4JS is the example of the snowmelt runoff model. And widely used one of the snowmelt model is the SRM, snowmelt runoff model, simply it's called. And now HMS has also capability to simulate the snow runoff from the snow-fed catchments. And the soil and water assessment tool has also capability to simulate the flows and runoff from the snow-fed catchment. And there are some models, but the like SRM uh, and some other models does not have capability to simulate the glacial melt. For the glacial melt, there are some other models. For example, uh, Australians updated one of their platform that is called Source, and they incorporated the GR4JGS model, and it has capability to simulate the snow melt, to simulate the rainfall, to simulate the snow melt, and simulate the glacial melt also. And similarly, WAPDA is using UBC watershed model, and UBC watershed model has also capability to simulate the runoff from the glacial melt. Hydrological models are classified either based on the input parameters or the physical phenomena. Based on the input parameters, the hydrological models are classified as lumped, semi-distributed, or distributed. In the lumped model, only single parameter is used. And in the semi-distributed model, that catchment is divided in further into sub-catchments, and and each catchment has its own different single parameter to simulate the runoff. Whereas in the distributed model has capability to simulate the runoff at each pixel. Therefore, it has the complexity increased with from the lumped model to distributed model. And based on the physical phenomena, call the empirical models or conceptual models or physical based model. Uh, Empirical models and similarly the conceptual models, as you can see on the right side, this is the figure that I have taken from the research paper of the Perrin. This is the basically GR4J rainfall model. It is it is a lump model, and it is a conceptual, because different processes are conceptualized at different stages, that how evaporation occurs after precipitation and water goes into the different stores and percolations and runoff generates. And this is basically the conceptual. And similarly, UBC also has a conceptual, also a conceptual model. And the physically based models uses actual, or you can say that exact hydrologic equations like SWOT model. It uses the hydrologic equations.
रिपोर्टें देखे ना हमारे रिपोर्टें हैं
ठीक है. Is there any question?
नहीं प्रोग्रेस रिपोर्ट से शो होता है ना कि
Hello, can you hear me? Ijaz, can you tell me about hello Ijaz?
Yes, sir. जी sir. Yes, sir.
Okay. This table basically, I have added this table to show you that how different models can be categorized based on the input parameter or based on the physical phenomena. Most widely used models like SWOT model, HMS model, and UBC and SRM models. I have added, so you can see, because this is a SRM model or a SWOT model. Catchment is divided into sub-catchment. Therefore, it is called the semi-distributed. Whereas the SWOT model, the approach which is used to simulate the runoff is physically based. Therefore, it is also called a physically based model. Whereas SRM model simulate the runoff based on the empirical equations. That is the degree day approach. Therefore, it is called the empirical model, and it is also a semi-distributed. Now I comes to the topic that is R. R is basically the open source language. First question is why R is used in hydrology, or what is the importance of R in hydrology? And what was the purpose of R? Actually, with the advent of new things, with the expansions of the data like remote sensing, data is available, and new softwares are developing, the growth of computational hydrology is increasing. Therefore, R is required to run these models. And secondly, R is the open source programming language. Because it's open source, it means it is available to all without any fee, without any charges. And this R was basically developed for the statistical computing by Rose and the Robert in 1990s. And now it is being widely used for various purposes. And in these slides, I have mentioned a few applications of our language because it is highly versatile and it has a wide range of uses. R can be used for data acquisition, like remote sensing data or any other data which is available on the sites, like, for example, NOAA, National Oceanic and Atmospheric Administration, has many stations data of many stations on the website. R can be used to acquire those data. Similarly, you can analyze this data using the R. And there are some models are also available in R that can be used to simulate the runoff in all. Ijaz, I think someone's
All the
mic is on.
participants are requested to keep their mics muted. Please.
Thank you. There are some statistical analysis can also be done using the R, and you can also visualize the data using the R because it has a advanced user interface, and well-developed geospatial and geographic information system applications can be run using this R process. It is very easy to run any process which can be done in the GIS platform that can also be done using R language. And R language, R package can also be used to generate reports and making the interactive presentations. And what are the advantages of R? Because it is very easy to use and it has very large number of online resources, and you can search whatever you have to need, you can search from the online resources. And another advantage is that the availability of the source codes under the open source license, or source code of different processing mechanism like GIS methodologies are open source license, and it can be run on all major operating systems like Microsoft, Windows, or Linux. With the with the application of R, there are about 13 to 14 hydrological packages which are built in this R language, and you can use these packages. First of all, I will start from the installation, how you can install this R language. R language can be installed from this link given on the this presentation, and you can see the window that will be open after clicking on this link, and you can download the any latest version of R available on the link. And every few months a new major version becomes available, and you can download any version from this link. There are some guidelines for initial users who want to use this R language to process their GIS data, remote sensing data, or whatever data which is required for hydrological modeling. R relevant content using the internet search engine are like expressions and packages. Okay? These can easily be searched from a dedicated search engine that is called RSeek. The link is given. When you will go to this link, you can see that I show you in the next slide that only the relevant material related to R will be available on this dedicated search engine. Actually, the initial hurdle which is faced by the users is the finding the time required to gain a basic understanding of R itself, and how to find the solutions on the internet and to navigate help files provided within the R. You can find the solutions from the internet, and also you can find the solutions within the R user interface. Therefore, there are many advantages of writing a script that because when you perform any analysis using R, actually you write a script, and that script utilizes some packages. When you write a script, it can be used and improved further by anyone. It is not only for you. You can share it with someone others, and they can use the same script to generate the input requirements for the catchment. Like they can use the same script to download the data, to merge the different tiles of the remote sensing data, to extract some information from the remote sensing data. Actually, these scripts can be reused, and that can be improved with time. And the same script can be reused to produce the given result, and therefore it avoids the duplication of efforts, and the same script can be used for different catchment. For example, initially the script that was prepared by the one of our organization for WAPDA, and the script was for Mangla catchment, and then I modified those script to process the model data of the Chitral catchment. Similarly, once you develop a script, write a script that can be used for any catchment to process the remote sensing data. This is the engine that I was asking, the RSeek, and you can search any type of information regarding R language. If you have not installed the R in your computers, then it is a facility available online. Servers are available that provide you the workspace for processing in R, and this is basically the link where you can make your own login. That I made my own login on this rstudio.cloud, this cloud server, and you can go to this cloud server to if you have not installed the RStudio, or if you don't want to install the RStudio in your computer or in your system, then you can use the online cloud servers by making your own account, and then you can run different processes on R. These are the steps for processing of data using R. There are different steps for processing of the data which is required for hydrological modeling. For example, you process the digital elevation model, you process the temperature data, or you process the precipitation data, and you process the snow cover data. All these data can be processed using R. You can not only download this data using R package, but you can also process. You can also done many different processes on the using the R. I will go into the details in the next slides. First of all, for example, if you first of all, first step is the downloading of DEM. Okay? You can download the DEM from the different sources like Aster 30 meter is available, but widely used digital elevation model is the SRTM, and this is the link which is given on this presentation. You can download the required tiles from this the SRTM link. When you click select the particular site, the information is shown, description you can see what tile you want to download. And similarly, once the tiles are downloaded, then you have to mosaic. You have to basically combine those tiles so that you can extract your catchment. Because, for example, in case of Mangla catchment, catchment was within the 4 tiles. These 4 tiles the catchment was extended with these 3-4 tiles, and you have to what you have to do to mosaic and crop. You have to use uh, the scripts. I will show you how you can write a script, and the script required the working directory where you want to want to add your inputs and outputs. And similarly, you have to name the input files. You have to add the coordinates of each file, and you have to mosaic. There is some process which is required for the characterization of elevation zone. Once you have merged, you have mosaiced your SRTM dam, then you have to characterize for the catchment for different elevation zones. If, for example, you characterize your catchment with the increment of each 500 elevation, then what you have to require? You have to require the catchment. Uh, you have to require the catchment area. Catchment area can be extracted using the hydrology tool, which is available in GIS, and then you have to project from geographic coordinate to UTM in the GIS platform. And this process can also be done in the R package. And then you have to resample. Resamples mean you have to synchronize the spatial resolution of different remote sensing data. For example, I have the dam which is available to me has a resolution of 90 meter, but the MODIS snow cover data has the resolution of 500, and I have to synchronize this. To synchronize the dam to the resolution of the MODIS, then I have to resample it. And then after resampling, elevation zoning and masking is done using the R language or the R package. To characterize the elevation of the catchment, you have to need the catchment area shapefile, and you have to need a projected dam in UTM, and you have to need an elevation zone defined text file. This box basically encloses the process which are done in the GIS, and the last process is done in the R package. And after when you process is completed, then you get this file. As you can see in this, you get a file after processing the data in R. You get the elevation zone. For example, elevation zone 1 starts from 501 meter elevation to 1000. This is the minimum elevation of that zone, and this is the maximum elevation of that zone. And these are the number of cells which are counted using the R package. And similarly, the last column shows the hypsometric mean elevation of that zone. And the you can see, you can calculate these different minimum, maximum number of cells and hypsometric mean of each elevation zone using the R script. When you run the elevation characterization of elevation zones, of different files will generate. For example, first file you can see, this is the first file shows you the uh, whole area of the Mangla catchment, and then elevation zones are characterized. This is the first elevation zone that was ranging from the 501 meter to 1000 meter, and the elevation, this is the second elevation zone. And similarly, I made about 11 elevation zones for the Mangla catchment. Similarly, one can generate as much elevation zones as is required using this script in the R package. After processing the digital elevation model and characterization of the elevation zone, because these elevation zones data is required in snowmelt runoff model and many other latest models, those models also require the elevation zones. Therefore, we process the digital elevation model. After processing, the next step is the downloading of temperature data. As in the previous slide, I showed you that the runoff model requires the digital elevation models information and the temperatures data, precipitation data, and snow data. This is the next step, the downloading of temperature data. Actually, the available data is, for example, NOAA satellite. We have a data available in the different parts of the country and as well for the whole world. NOAA has made available for us. The temperature data is available as well as the precipitation data is available. In this picture, you can see in our catchment, the data of Srinagar station was available, and we downloaded this data using. You can also download this data using R or as well as from the direct link given in this slide. There are many climatic stations data which is available. Actually, the Global Historical Climatological Network provides that. Yes.
Actually, one participant has a question, but he don't have the mic. His question was that can we download 10 meter or 12 meter DEM from the open source platform?
Currently, according to my knowledge and according to the literature, I suggest that the SRTM data is more reliable. Scale, the 30-meter resolution is enough, and to process, because we have the limited computational resources, and if we want higher accuracy, then I would suggest the data of SRTM with 90-meter or 30-meter resolution can be used.
I have a question.
Okay. Okay,
I want to ask how we are going to interpolate data. For example, in GHCN, there are so many gaps in data. I found that whole of the months are gone. So how we are going to interpolate on monthly basis, yearly basis, and daily basis?
Actually, model have to require the data. You can, for example, if you see the GHCN has missing data, then there is no any, I think, proper solution to fill the gaps. However, you can fill the snow cover data. It is very difficult to fill the precipitation data or any other data. However, you can fill those gaps using any satellite data which is available on the internet. You can use that.
Is it appropriate to use any correlation technique with any of the other stations for filling the station data?
Use, but it because in a at a catchment scale, data is very the conditions are not similar. Therefore, I suggest that the remote sensing If you find any remote sensing data suitable, then use it. I think that is more appropriate uh, than than using the other stations data, because the
So,
conditions varies in a single catchment. Conditions varies.
so is there any remote sense temperature data available online, which is appropriate and which we can use for distributed modeling?
I have not. I am not confirmed about this. However, precipitation data is available. Different source you can see the different sources. The precipitation data is available.
Okay, thank you.
You can one can use the single stations data for a model, and one can use
Bashir
also the.
Saab has
So I would like to ask that how much uncertainty is there that as you have taken only 1 point for temperature data that is Srinagar. So the mean area elevation is slightly different. So how you extrapolate the data for other elevation higher than the Srinagar? And secondly, as our colleague, I asked for the temperature data, the satellite based temperature data is available from GPM data source. Thank you.
For the temperature data, you use basically the labs temperature labs rate. However, you can for the precipitation you can use the satellite data. You have two options. You can if you have the station on each elevation zone, which is very rare and not sometimes possible, then you can use the satellite precipitation data like NOAA that is available on daily basis. I think I should.
please continue, Dr. Ashraf Saab.
Basically, data sources are available. Precipitation and temperature data is available from GHCM, and GHCM contains record from over 100,000 stations in 180 countries and territories. And for Pakistan, I think more than 30 stations data is available from the GHCM. When you go visit the site and want to download the data, you can see that temperature, maximum, minimum, and average temperatures are available for that station, and you can also see the summaries of the precipitation. And this is the extent of NOAA rainfall raster. You can download this raster to for your catchment, and this raster is has a resolution of 11 kilometer into 11 kilometers, and for the synchronization, as I told you before that, because when you use the SRM or any other model, or you want to calculate at a single cell values, then the cells uh, have a same resolution. So synchronization means because I am using at a 500 meter resolution, I also converted my 90 meter depth into 500 meter. Therefore, this is the larger resolution, and then this is also required to synchronize this data. So and then it to project it and resample and clip to my catchment. And this is these all was done using the R script. And this is the method. One is the manual. One is the manual method. For example, from GHCN, you can manually download the data of temperature and precipitation. And there is the second method is the automatic method. You can use the R package to download and process the precipitation data. So to download the NOAA precipitation raster, you have to need of catchment zones. As I show you the files in the previous slide, the different 11 catchment zones files were prepared using the R package, and then the stations information is required and in Excel form. This is for NOAA data and the libraries, because when you run the R package, you need the libraries. Libraries are basically, in libraries, codes are syntax and codes are given in the libraries. You have to link those libraries with your package. When you install the libraries, you have to need the RGDAL library, raster, and XLS to process this NOAA data. And then once the data is downloaded, then you have to calculation of precipitation for each elevation zone. To calculate the precipitation for each elevation zone, you have to need a catchment file, elevation zones files, and you have to need the following libraries. And similarly, when you calculate when the precipitation is calculated through this second step, then the precipitation analysis is made using the R package. All raster download will be processed in a single run, because you have downloaded the raster, and these raster, there will be more than 1,000 files. For example, you have for a year you have a 365 raster files, and using this using a script in our language, you can process all the rasters within a single run, and following libraries are required to process the precipitation data. And the once you have processed the digital elevation model data, then you downloaded and process the temperature and precipitation data, and at the last you have to download and process the snow cover data. Generally, the MODIS snow cover data is used for the hydrological modeling. The steps are follows. First of all, MODIS data is downloaded in R using R script. Then R script is used to convert HDF files into TIFF files, and project. And after the TIFF files are used to remove the cloud, then removal of cloud cover is done, and then the snow cover cells are counted, and so snow cover gas free data is prepared using RScript. Downloading and processing of MODIS data is as follows. To download the MODIS snow cover data, you have to mention the start and the end dates. You have to mention the login in the script. You can make your own login on the MODIS site, and you can use the FTP server to download the MODIS data. So you have to install the libraries also. And this MODIS data is converted because when you download, these are the HDF files, and these HDF files are converted into TIFF using the script. When you convert these into TIFF, you have also to resample, reproject, and to those files. This is very important that all the raster files should have same resolution. All the rasters files should have same projection system. Therefore, you have to resample and reproject the each files which are being used in the hydrological model. And then when you convert the file into TIFF files, then you have to eliminate the clouds. The clouds free images can also be created using the R script. In this figure, you can see initially when I downloaded the MODIS data, in the upper figures you can see these black clouds are shown in black colors. You can see when the script was run, uh, the below figures shows that clouds have been removed from these tiles. The single run, a single script was used to remove these clouds from all the downloaded MODIS data. Once the processing is completed, you have to calculate the snow cover area for each elevation zones. Then you also run a script for snow cover analysis, and the snow cover of each elevation zone, as you can see in this text file. A text file is generated using R script that calculates the snow cover area for each elevation zone. And then a gap-free image is produced. You can see here this script also basically sees the the image before the clouds and after that image, and it interpolates those images and calculates the snow cover gap free images. Thank you very much. It was. Uh, I can also want to show you one more thing. I share you how you
Sir,
can use the R
sir,
script.
before you share, I think Ahmed Saab has a question. Ahmed Saab, please.
Assalamu alaikum, Dr. Ashraf.
Walaikum
Uh,
salam.
I have a question from you. As you said, you have to download rainfall data as TIFF files, okay?
Yes.
For example, I downloaded this TIFF files as a precipitation data. It is like thousands layers,
Yes.
thousands, or for example, for 1 year, 365
Yes.
data. How I can make it as one data, and for each day I want to give the date of that day. For example, January 1st, 2010, January 2nd, 2010, something like that for my, stacked or beaked raster data. Can you?
When you download the tiles are saved with unique numbers with dates, and you can mention you can mention this in the script, that what should be the format of the data that is downloaded. You can mention in the R language script. Once you mention in the R language script, whatever the format, the same format will be used to assign the date or any other whatever you have mentioned. If you have assigned the date, then date will be each raster will have mentioned the dates when it will be downloaded.
Thank you very much.
Sir, I have a question regarding the modest data. Were you were using its product, or you were using the yearly based composite or annual mean something? Because the land cover keeps on changing, fluctuating as per the time scale. If I'm taking the 3 months average, the land cover classes will be changed somehow. So, which specific time frame you recommend for SWOT or other models as well as model that you are right now? And so the second question is that does
Please repeat your first question because your voice is not clear.
sir, sir, I wanted to ask that, what specific products you were using for the model?
What?
Specific products you were using for the model for the snow cover.
Sir, your voice is distorting. Can you write your question?
Sure, sir. I'm sending you on WhatsApp.
Okay, I want to show how the R language works. Okay, I want to show. Please, I share my screen again. One minute, please. This is I have opened the R Studio. Okay, you can see R Studio is basically the user interface of our language. Okay, and this window where the cursor is blinking, you can see. First of all, we add the library. For example, I wanted to mosaic the different rasters. into a single raster. Okay, then I have to need a library. First of all, I write here library, which is raster, where code is given. Okay, then I set the working directory, okay, where the inputs and the output files will be located. And then I give the name for a newly mosaic raster. For this, I had downloaded the 4 tiles for my catchment, and then I given the names, and then I thought according to the extent whatever I was required, and then I used this function to mosaic the raster. As you can see at the line 18, where the cursor is blinking, this is used to mosaic the rasters which are clipped to the extents given in the lines 14 to 17. And then at the end, what will be done? Our new raster will be write in the same folder where the working directory is set. Here I run one by one, and you can see the new raster will be created at the working directory. First of all, when you write the script, this is the script. When you write the script, then you run one by one. When you run it one by one, you can see in the console if there is no error, then it will be go okay. If there is an error, it will be appear in this window. Now it's working. Now here you can see a red is shown where stop is written. Okay, now it is completed. If it keeps on blinking, it means process is is continued. If it stops, it means work is done. Okay, I show you the raster which is created using this script. Here, this was the basically working directory where different tiles were downloaded. SRTM dem data was downloaded, and at the end you can see SRTM Mangala mosaic. This is created just 1 minute before. This here you can see, and this is the actually the mosaic file which is created after running the script that I used. This was only for demo. You can make all these processing using the same methodology, but all have different scripts. And any other regarding if someone has question regarding this, then he can ask.
Okay, sir, thank you. Actually, Ahmed Saab asked, will you share the source code of the R language? I think it will be fine. We can share the data, the presentation and the source code to the participants at the end of this webinar. And one of the participants have asked that what specific Modis product was used for snow cover. Temporal scale varies in land use, so early annual composites are fine enough for simulations. If I use the Sentinel-2 for snow extents, it gives 10-meter resolutions. But my question is that should I go for annual, yearly, or average? One of the participants have asked this question.
Okay, normally most of these runoff models require the data on daily basis. Therefore, you have to need the data on daily basis. So for this, for example, for Mangla, we use the Modest 10A product. Okay, that was downloaded on the daily basis and processed.
Okay, Umair Rasool Saab has a question, I think. Umair Rasool, please. Okay, is there any participant who has question about this R language?
Actually, this was from my side. This was only the introduction and to make you all familiar about the basics of R. The actual practices required weekly. I think the training that will be extended to 1 week or 2 weeks to carry out the all procedures that I mentioned in the slides. Therefore, this was only the introduction. And I think, I believe you will have new things that how you can download the R, how you can have different, different sources where from you can get the data. And this was only about the introduction.
I think in future we can also organize more advanced or detailed
Yes.
webinars or workshops in which details can be disseminated regarding the R data downloading using the R language package. And if any of the participants have questions, then they are welcome. And otherwise, we can move to the next session of the webinar. At the end of this webinar, we will share the presentations and also share the source code which participants were asking. I think it is fine with this.
Excuse me, sir.
Yes. Please state your name and ask your question.
My name is Salman Khan. I would like to ask one question from Sir Arshad. Ashraf.
Please.
Sir,
Yeah, please.
Sir, can we use R for bias correction of climate data? As we have GCMs and RCMs data, which are incorporated with different kinds of uncertainties and biases. So could we use R for bias correction techniques?
No, I have only go through the process that I have shown you, that how data is downloaded and then it is processed so that it could be used in the snowmelt runoff model.
Okay.
I have. You can search from the RCEC engine. As I mentioned for the initial user, I consider myself also the initial user of this R package.
Okay,
and you can also
okay,
search from the dedicated search engine, the RCEC.
Okay, sir. Okay, sir. Thank you.
Hello.
Yes.
Yes. So I'm Uttam. I'm from University of Guelph, Canada. Just to respond to Mr. Salman Khan's question, actually R can be used for bias correction. And if you are interested, I can provide you the scripts that I used for bias correction because I worked using R and different bias correction techniques. So maybe by the end of the presentation, I can actually share some of my scripts and the papers that I wrote on the same to the whole group. So if you want, you can just communicate with me at a later date. Thank you.
Okay.
Thank you.
Excuse me, sir. I would like to thank Uthman. I'm Salman Khan from Lahore Leeds University, Faculty of Engineering. Actually, I did use quantile delta mapping for bias correction of climate data, and I would love to talk to you just after the session. Thank you so much for your kind response.
Yes,
so
no
nice.
problem. Yeah.
Thank you.
Okay, thank you very much. I think it's a two-way learning process, and we can, after the end of this webinar, we can arrange or we can share the contact details of the participants at their requests, so they can further discuss this in detail. If any other participant has a question, he or she can welcome. They are welcome, or we can move to the next session of this webinar.
Yes, sir. I have a question to Dr. Ishaq.
Please state your
Yes.
name and ask. Proceed.
Sir, I'm Marusu studying in China, Beijing Normal University. Sir, my question is, could we generate latest DEM using R? Because we have in SRTM, data is 2014, not 2020 or 2019. Could we use R to generate the updated DEM?
I have not worked in this regard because the purpose of this session was only to make you familiar about the different process that I shown you. I think
Yes, sir.
Uttam Gavir is I think is expert. He will show you. And further, you can actually the SRTM data is based on the satellite which was launched in 2002. This is the data of 2000, February 2002, and the
Yes.
same is being used. And if you want to generate your own DEM, I think you can do this. I will search and I will request also Uttam to help you. And as Dr. Ijaz suggested, he will share the contacts of the person so that we can learn from each other.
Yes, we can generate from RGS. RGS
Yes,
has no
we can
problem.
generate. Yes,
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 RGS has
we
no
can
problem. Just my question is using R.
I have to search this. I have to
Thank you,
find
sir.
this.
Thank you. Thank you, sir.
Okay, we have noted down your questions, and after this session, after this webinar, we will share the related materials or share the details of the more relevant persons. Actually, this session was only for the beginners. Like they can introduce with the R language package that it can be used for the downloading the data, how we can download the satellite based products data and process it. This is just was a beginners session, and now I think if no one have the question, I move to Dr. Mudassar, who will give you a introduction to the UBC watershed model, and he will also provide you the hands-on exercise session. And for this, I have already requested in the guidelines as well that participants can use two dual devices, that either they can use their mobile phones to get online from the Teams software and use their computers or laptops for the practice. Now I hand it over to Dr. Mudassar. Dr. Mudassar is working as a lecturer in Center of Excellence currently. Dr. Mudassar, please, over to you.
Thank you very much, Dr. Ijaz. Can you reduce your echo? Dr. Ijaz, can you confirm me that the screen is online now?
Yes. Yes.
All right. All right. My name is Dr. Mudassir Iqbal, working as a lecturer in Center of Excellence in Water Resources Engineering, UET Lahore, since April 2020. First of all, I would like to thank Dr. Ijaz for helping in organizing such activity which was difficult for me to handle alone. And also I would like to thank Dr. Noor Muhammad Khan, Professor and Director, Center of Excellence in Water Resources Engineering, to continue such type of webinar series from the center platform. And I also would like to thank Dr. Muhammad Ashraf for sparing the time and give a brief comprehensive presentation on using the R language for data downloading remote sensing products. Okay, well, the part that I will present is hydrological modeling for snowpack catchment using UBC watershed model. The outlines of the presentation is first the introduction of the UBC or hydrological modeling, and then objective of this presentation, and also to prepare some files for the inputs of UBC, and then editing of those files like watershed file, and other about some calibration procedure for the UBC model. And after getting the results and its presentation, and besides these outlines, uh, we also complete some hands-on exercise that we have shared. The organizers and his team shared the hydrological data for exercise. Let's start the introduction. Since we all are aware that Pakistan has one of the largest river network, which consists mainly of Indus River, Jhelum, Chenab, Kabul, Ravi, and Satluj, and the contribution of inflows of each river in this system is defined according to the seasons. And in rivers, Indus and Kabul are the dominant source of water, while in Chenab and Jhelum, in Indus and Kabul, the dominant source of water is, and also same as Chenab and Jhelum, are snow and glaciers melts, and as well as monsoon in summer season. Moreover, about the importance of the UBC watershed model, that our director Noor Muhammad Khan also elaborate that we have our the hydropower potential in the mountainous areas, and the development of the projects are exist in that areas. So to find out the water availability for the hydropower projects, and researchers and organizations are using different hydrological model or build their own model. And say in the developed model, researcher organization also use the UBC watershed model. UBC watershed model is a semi-distributed hydrological model which divides the entire watershed into the several elevation bands. The model, the model was this model was developed for Fraser River system in British Columbia by Anthony Pipes and Michael C. Quick in 1976. This UBC further enhanced and tested. Now we have its user-friendly window-based model by Michael C. Quick in 1995. He produced it. Its script produced window version in 1995. This model computes daily and hourly watershed outflows using daily data, daily precipitation or daily temperature data. Since this model was originally designed for forecasting runoff from mountainous catchments, for this reason, model is divided into the area elevation bands to deal with the orographic effects, orographic gradient of precipitation and temperature due to the mountainous catchments. We have in this model some routines, some model 1, some model 2, some model 3, or we can say that we can divide its structure into 3 submodels, 1, 2, 3. The first model divides the precipitation and temperature data to all elevation bands, like it deals with the elevation area bands So temperature and precipitation data divides divides point data or temperature data, precipitation data divides to all elevation bands in this routine. And the change of temperature with elevation governs the precipitation as snow or rain, and also melting the snowpack and glacier in this submodel in this part of the structure. The second deals with the soil moisture that controls the runoff, or we can say it distributes the runoff into four parts, like fast runoff generation, medium runoff generation, or slow runoff in upper groundwater, and extremely slow runoff in the deep groundwater part. And the third is related to its routing and release of runoff to the outlet. As it routes and permits the release of runoff to the outlet of the watershed, and this routing is based on linear reservoir theory that assures us the conservation of mass and water equilibrium. Now, next is, in this presentation, we have our objective that make the new users familiar with this model, with the UBC watershed model. And the second is how we prepare the files for the UBC inputs. The third one is a brief idea regarding the calibration procedure. The detail we can also for the calibration we can also search many articles and its manual. The next is preparation of meteorological data files. Normally, we organize our data or the meteorological data. If I talk about the Excel, that in date, we keep date in first one column and the data in others columns, Tmax, mean, precipitation. Or we can also arrange our data by keeping year in one column, second in month in second column, and day in third. Next column, data in the next columns. So similarly for the UBC, we keep the same format, but after the data we add one more column, like the data finished up to the column G, and the next column H, we just add a double space in the column and drag for all rows. Next is, this is a XLS file. Now we need to gather all the date. We need to gather the date and the data in one column. Like let's say the I column. And for
kindly
this,
sir, please tell us about double space again. What is double space?
Just we need to press 2 times space in the next column. I think if you understand, then just
the column will be empty. The column will be empty with no value.
Yes, will be empty. Yes, it will be empty.
Okay, sir.
Just
okay,
double
sir. Thank you.
And the next step is to gather this data with date in the next column, and so for this I have provided to organizers that of hydrological data or Excel prepared data folder. So we can see the steps. It's just simple. The researchers persons have their own choices how to manage this data, but the point is that the data should be in the string command, like easy to handle. Not should be the like reference or value errors, provide the value errors or reference error in the common errors in the Excel. So for gathering, just use the command of AND, column to column, and next column and next column, like this. So we all the things in one column, and then we need to separate or copy this column to the next sheet or another Excel workbook. Then say just we need to here I will explain the header. The heading of this column should be the starting date of the data and ending date of the data. This should be the heading of the data column. So here in this slide, a slash is a miss after the month. So we can keep the slash, and then we need to save just a Excel file to the comma delimited file. After saving the comma delimited file, we need to just change its extension. Dots, we can replace the file name .csv to .adm. This is the UBC input model format. Like firstly, this model was a binary DOS based, so we need binary data, and then we can change that binary to ASCII for getting the same data into the window structure. The next is, I think if it is clear, then we can move on the hydrological data file preparation. If somebody have question to prepare the ADM file, then please she can raise the hand. Or
sir, I am not clear about how we will change the CSV extension into AES or ADM. It is not clear, sir.
Okay, I explain. Just close the file and keep any name with .csv. Just like I'm not sure about you can see my screen or not. If you can see, then please inform me.
Yes, sir, we can see.
Yes, we can see, sir.
So, yes. Okay, like this. This is a .csv. We need to just change its name, like rename it and change the extension, like ADQ. Simple. It is the error of the file name already exists in this folder. So
okay, sir. Understood. We just have to change the last 3 digits.
Extension.
Yes.
Yeah.
Okay, sir. Understood.
Sir, we have ADM and ADQ. What is the difference between ADM and ADQ?
Yeah, and we can just we can remember from the M and Q. M is for the metrology data and Q is for the discharge data. It is a short term. Like these are the files for the ADM file for metrology, and ADQ is file for the discharge or runoff.
Okay, sir.
It's a file format for inputting the data in UBC watershed model.
Excuse me, sir. I have one question regarding input files preparation.
Yes, please.
I'm Salman Khan from Faculty of Engineering, Lahore Leeds University. Unlike SWOT model, in case of SWOT model, when we were preparing input files for each climate station, MET stations, so we were having precipitation files along with T max and T minimum, maximum temperature and minimum temperature separate. In this case, if for example we have 10 stations, climate stations, or 20 climate stations, so all we need to
20 files.
All we need to have only 20 files for UBC watershed model.
Yeah,
Am I clear?
But yes, you are clear. But UBC has a limitation. Only it can be, we can input the 5 climatic station data. So we can
only 5 climatic
yes,
station. For
only
example,
5.
as I'm working on, I did work on Mangla watershed using SWOT
Yes,
model on
yes,
climate change impact assessment. And I
yes,
used SWOT model for that. But the problem is SWOT model is not incorporated with glacier melt component. And
all right.
now I'm willing to use UBC watershed for comparative study. So
Yes.
is it possible to use UBC watershed because I'm having 21 climate stations in my watershed?
21 climatic. Yeah, you can perform the UBC 4 times, and or you can divide in the whole catchment into the sub catchments, or
It
four
means
catchment types. Yes,
I would need to run the model 4 or 5
models.
times. Yeah.
Yes, 4 to 5
Okay,
times.
sir. Okay, sir.
Then you need to collect gather the all simulated data for the calibration or validation.
Okay, sir. Got it.
For
Thank you.
showing the whole picture of the
Okay, sir.
watershed. Okay, next is
All right.
the preparation of the hydrological data. So the hydrological data also, yes. The next, these are the same steps for the meteorological data files are the more. So the window in this slide is where the window is pasted for the command limited format, and just change the file. Yeah, just change the file extension that .csv2.adm, and we can open that ADM file with Notepad, simple Notepad or Notepad Plus, and we also sometimes we see in that file the quotation mark, uh, double commas, or quotation mark. We can also remove or not remove, does not impact on the running the UBC input. We can keep the double quotation mark, or we can remove. It's up to the users. Next is the hydrological data file preparation. So we for the model calibration, we also need hydrological data like discharge. So keep same same as metadata. We need to keep the date, collective date, or discharge data in the columns. We can gather at the together, or we can keep in the next column and save as, say, command elemented file. And then similarly, the extension like ADM. Before in the previous slide, we changed the extension to ADM, and we can change the extension now ADQ. All right, understandable for the.
Yeah, I have a question, sir.
Yes, yes.
Yeah, so like Dr. Salman was just mentioning that in SWOT models, we generally have a lot of temperature stations, precipitation stations, even with the flow stations, we have an easy way of like specifying the location, right? As I see through the meteorological inputs here, we did not see any information on their lat long. So are we going to specify their location within the model?
Yes, in the next slide. Of course, we will. When we will go to the next slide of watershed file, then there we have this option to keep the location of the climatic station.
And same is the case with the hydrological stations also, right? Then.
Yes.
Okay. Thank you. Yeah.
Next is so after preparing these ADM or ADQ files, we need to change or change these files to BDM
Excuse
or
me, sir.
BDQ. Yes.
in hydrological data, we do not need to use that command that we previously used for precipitation data and
Double
temperature
space one.
data.
Yes. Double space one. No need to use.
Okay, and no need to combine all the columns into one column like we did in precipitation data.
It's up to you. If you use the comma, like you can see column A, we have a date. The second row.
Yes, sir.
2003/0101. If you use the comma in the end of the day, then no need to keep no need to keep in the next column, and you can paste 11.8 value to the column A by using the comma. Actually, it's a comma delimited file. Here we do not use because it will be automatically comma delimited.
Okay, sir. Fine. Got it, sir. Got it.
The next step is to convert our input file ADM and ADQ to BDM or BDQ. So in this step, to convert the files extension, we need to use UBC watershed model. So in this by when this users start the model, then this is the interface of UBC watershed model. Here we have a menu bar, icon bar, and in the menu bar from the tool menu we can convert. We select the input data conversion utilities option to convert the ADM or ADQ to BDM or BDQ. All right. In the hands-on exercise, definitely we will perform this step. Next is this is a conversion window. How after clicking the input data conversion utility, we this dialog box will open, conversion dialog box open, and here we need to browse our file, ADM file for the conversion, and just press the OK. It will be converted automatically from AES 2003. So AES 2003 file name is a climatic station file name, and with extension ADM. It will convert. Just browse it, and it will convert by clicking on OK. So after by clicking the OK, it will ask that to check some boxes. It will be about the missing data, how it will be it deals with the missing values in the meteorological data. Then the conversion tool confirms from the user about the start date and end date. And finally, we need to click convert now. It will be converted to BDM or BDP. The next is the watershed file, WAD file. It's very important file in the UBC model because it controls all the things in the UBC model. It has all the information related to the watershed. So there are 10 types of the like controls or steps we need to deal in the WAD file. First is the time and date, about time and date. Second is the met and flow data. Third is the elevation and parameters of climatic station. The fourth is a distribution of met variables. Fifth is a snowmelt function, water distribution, initial conditions, and outflows. The last one is about the outflows components from the different hydrological cycles. Editing. The next is the editing. We can edit the WAD file by two ways, like WAD file also can be open the notepad, or also can open through the window, through the software. So through the software, we use the file menu, and we use the file menu and click open WAD files. Then browse the in the hands-on exercise that we will perform in the end of the presentation. We have provided you WAD file .wat. Just upload, just browse that file, and then when we will browse the WAD file, the left side files list panel, the two files that we previous slide, BDM or BD2, will be appeared. It will be the sign of that you have. It will be the sign that you have successfully converted, and your file is successfully running in the UBC window. Rating is continued. So from the tool menu, now we can assess our WAD file from the tools. First step was the browsing, uploading the WAD file. Then now is editing, edit the WAD parameters, or edit WAD file. So after clicking the edit WAD parameters, the model asks create a new WAD file, edit existing WAD file. We can edit an existing WAD file because we have provided the model .wat file. The next is when we select the edit an existing WAD file, so we can see the below dialog box. In the previous slide, the descriptive WAD file have all the controls, and here we can see same controls one by one: time and date run control, met elevations. Or here, if we click on the, like here I highlighted description watershed, then the below it's a panel appeared, and one by one we can edit. One by one we can edit the WAD file from one. Then we can, if we have something need to change, then we can save it again by choosing the save or save as options. Next is, in the previous slide, all the controls we can edit here in the window, in the WAD file window, or not by opening it in the notepad. But the fourth one, description of watershed, we need if of course we need to edit or input in this control. So for this we need to analyze for our catchment. We need to analyze some information about the watershed. We need to our catchment characteristics using using products of DEM, using products of elevation, land use, and glacier. That are the input for this WAD file. You need to use ArcGIS. So the next is in that watershed description file, we need to provide mid elevation of the band, as I have explained before. That the model use the elevation area concept. So we need to provide. We need to provide the elevation of each band. Mean elevation. We need to provide mean elevation of each band. So for this, I suppose that it's a GIS work, and most of the users now are frequently use the GIS, or we can learn GIS from our friends or students or teachers. So just add the watershed layer in the GIS, To get the mean elevation, we need to perform the following steps. Firstly, add the layer of watershed DEM, go to the, then go to its layer properties and select symbology tab, and or we need, actually we are making a bands or elevation zones or elevation classes. So for making the band or classes, we need to perform these steps. So then after performing in the yeah, in the UBC, we can uh, it, it can we can maximum input 12 bands of the elevation or 12 classes of the elevation. Okay. But we also suppose that 4 to 8 classes of the elevation or band are better. And mm, then from the properties dialog box or symbology or classified, and there we need to see the mean elevation of each band. Okay, and here we need to put two things: mean elevation uh, each band or area of each band. Area of each band we can get from the attributes of the DEM file. If we have a 90 counts and counts in the after classification uh, we have counts of each class. Then just our multiplication with the DEM resolution, we can find the area of each band or area of the elevation class. The second part from the GIS, we need to get the frosted fraction of area in the each band. In the WAD file, which is as it is represented as COTREE. So similarly, we need to collect first land use data of our catchment where we are performing hydrological modeling, and then and with that product we have also information about the classes, about the land use classes. Like here, it is a Clam watershed land use data. So with the legends, we can see rainfed cropland, uh, bare areas, water bodies. These are the requirement to. Uh, this is our requirement to fill the WAD file for description of watershed. So same like we did in the previous slide for the DEM, we need to add layer of the watershed land use. Then we need to we need land use data for each band. So before we also converted we have to convert it our elevation classes to the polygons by using spatial analysis tool and extract land use area under each band. So you spatial analysis tool will be used for this process, and under each band we need to calculate the land use area of each elevation class with each elevation polygon. Right. And the area of the particular land use class in each band we can also find with the count and with multiplication of counts and imagery resolutions. We need for the WAD file two things here: forested area fraction and impermeable area. So we can get these two things by performing this step.
Excuse me, sir.
Yes.
Sir, I have a question.
Yes.
Basically, when we are using land use data and soil data for SWOT, so we are basically assuming land use and soil data in future projections. We keep the land use and soil as same throughout the time slices for 100 years or 60 years or 80 years.
Okay.
Do we have any component in WBC watershed model to count the variation of land use and soil data while doing future projections for stream flow or sediment transport, etc.?
I think same way like in Sawal, for the future we can make the scenarios, and here also we make the scenario. Actually, this model UBC model mostly used in the mountainous areas where the water met from the snow and glaciers. So we
Yes,
here
exactly, sir. But
so
in case of
here 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 we for the future we need to make the scenarios similar we do for with the Sawar. Here also we make the scenarios for glacier mats like 20%
yes,
glacier
sir.
melt is increasing like this. So this is the
Sir,
land use changes for the future.
we have a limit. We have a limitation in SWOT that we are only using precipitation, maximum temperature, and minimum temperature, which is varying in different scenarios, like RCP 4.5 and RCP
Fine.
8.5.
Yeah.
Do we have any which counts the land use and soil data variation with the passage of time if you are going to project stream flow or sediment transport? So could we have any component incorporating the land use variation or soil data variation uh, for analysis? I basically what I'm going to
Actually,
ask. How
yeah,
can we differentiate
the
WBC
future
watershed
variations future
in this
variations
regard?
you mean that how we tackle the future variations in the UBC watershed model.
Exactly,
Yeah.
sir. The land use which we are the land use which we are having now right now
Yeah.
would not be the same just after 50 years or 100 years. So we would
Okay,
have a
okay,
lot
I
of
am noting.
urbanization, deforestation. Exactly, sir.
Okay, okay, I am noting your point, and in here, I don't think so in the existing UBC watershed model. It has, but it has also GIS. We have also UBC with watershed mapper, like inclusion, like input all the things through GIS in the UBC. So there we can generate the scenarios for variation, future variation, but that will be also by making of ourselves, not with our future products, not any product is available for
Okay, sir.
future variation.
Okay, sir. All right.
So
Thank you.
in the here in this slide, the at the bottom, it's a table we can make and we can mosaic our classes, land use classes, and then the class numbers, their total counts, and the band wise within band one band two, how much counts exist in the irrigated cropland. So in the last is a resolution of the resolution of the grid or resolution the imagery. We can multiply counts to the resolution of imagery to get the area. Next one is the inputting of the glacier information in UBC WAT 5. So for this we need to collect the first the glacier file from the glacier inventory. So after getting the glacier file, then the same steps we can repeat, like especially in this to extract the glacier area under each band and calculation of the glacier area of each band. These are the requirements for the description of watershed, where we need to put as a parameters. The next is a calibration procedure. Simply, calibration can be completed in three steps. We can name it as a stage one calibration, stage two, and three, and also we we say that parameters are divided into three groups. As I also like model structure is categorized in three submodels. Similarly, parameters also can be categorized in three groups. related precipitation, water, and routing parameters. So stage 1 calibration, stage 2 calibration, stage 3 calibration. It means that we need to, the next slide, we need to set the stage 1 calibration. The parameters important in stage 1 calibration are or can found in the distribution of meteorological variables list. Distribution of a meteorological variable is a main control in the WAT file. So in that control we can find these parameters, and we can stage 1 calibration means we need to adjust firstly adjust these parameters, and then the others are no need to change, or just fix as the given in the WAT file by default. Then we need to run the model and check our statistics, either the calibration is okay or not. Then we need to change. Then we need to go the stage 2 calibration. And these parameters are related to the physiographic condition of the watershed. So the here and also we have stage 3, but where we need to go, when we need to go, this is important. So one by one we need to go in these calibrations. And in the UBC we have more than 100 parameters. We cannot. It will be a very time-taking process if we change one parameter at one time and run again and again. So that's why in the UBC we have 3 stages of the calibration. Okay, and the UBC also tested and applied in the Himalayas range since the many years, and developers also worked on the Himalayas range and fixed their calibration parameters. So in the stage 3 calibration process deal with the gradients of behavior in the watershed. It is a very fine-tuning process. Gradient can be assessed because the snow melt process tend to be most active in the few elevation bands at a time, starting at low elevation early in the season, progressive upward as the snow line recedes. So these are the we can also find that definitions, their ranges, and their ranges of the parameters, and from the manuals of the previous published literature. Here I'm telling about one study that the article title is ranking sensitivity calibrating parameters of UBC watershed models. So in this study, in the UBC, the authors tried to rank more sensible parameters for this UBC, and they list out these parameters. And I also suggest, and I also use these by keeping these ranking in our model studies. So in the next is running the UBC model and its results or its statistics. After the adjustment of parameters, we can run the model, or we should run the model as shown from the file, from the menu bar. We need to select run, and in the run menu, UBC watershed model, and then just it will after running it will not show anything, and then we need to run statistics. In the when we will click the run statistics, then this dialog box will open and ask about the confirmation of the date, start and end date, and statistics for whole. Always, I remember, we should remember that the statistics for whole period box should be checked, and output file name should be the default same as our bat file. The output file name will be the same as our bat file. The next is simulation, or results or graph or reports, how it looks in the UBC. So we can also view our statistics report in the notepad, then in the text form, or also from the window structure in UBC. So from the view menu, we can see the view statistics report. In the statistics report, we have coefficient of efficiency and coefficient of determination, the second last columns. And this coefficient of efficiency or determination help us to decide whether our calibration procedure is up to what extent it is good. So this is a graphical window. By click, we have also like on the left side of the UBC model, we have file list panel. By running the Watershed model, we have created .bdc file. When we will just click on the BDC file, double click on the BDC file, it will open the graphical output or graphical results of the calibration. So we can set the chart. We can set the chart configuration from using the chart menu from the menu bar. Yeah, runoff components from different hydrological sources. For getting the for viewing the melts from the glacier, snow, or it's the groundwater contribution, or it's a rainfall contribution. We can see the icon bar. The last icon is a select component icon. Choose this icon, and this dialog box will be open. And here we can see the first is observed flow, second is calculated flow. Observed means we have provided in the BDC, we have provided in the ADQ file, or that later we converted into BDQ file. The third box is a difference in flow. The fourth one we need to check, and we need to check fifth one also, sixth and seventh for displaying the different melts from the hydrological sources: snow melts, glacier contribution, rainfall outflow, groundwater from upper and deep zones. And these are the components that the window is asking the user which type of the you want to see the graphical results. By checking these components, we can see the graphical results window like this. The legends are observed, they are calculated, snow melts, glacier contribution, rainfall, groundwater, like this. So in this presentation, worked with Kalam Hydrological Station. Kalam Hydrological or Kalam Catchment is located in the Swat district, or it's the upper basin of the Swat river. Is a little bit about the information. How we can get the output file in TXT or XLS file. Like in the previous slide, we have graphical results. How we can get it's a TXT or a XLSX data from the UBC model. So it same like we from the start we converted our ADM or ADQ files using the conversion tool from the tools. So it is a just reverse process. We need to select file name, our clam for BDC, that is, it will be created when we will run the model. Just browse the output file and convert. It will be saved. It will be saved as a .bdc file. That .adc file. It will be saved as a .adc file that we can open in the notepad, or we can convert that file to CSV or to Excel SX files. Okay, this result file have different columns. We can say the first is date. The first is date one, and the second is observed flow. Third is calculated flow. Fourth is difference between observed and simulated flows. And the next four columns are highlighted. These are the contributions from the different hydrological cycles components, like from glacier, like list wise, as we try to check boxes from the in the previous slide. It is related to that glacier melt, snow melts, rainfall, groundwater, like this. Okay. We have also some limitation to use the UBC watershed model, which use the number of elevation bands up to 12. We use normally we use 4 to 8 band for the data easiness, to handle the easiness, because all the data is need to manual input. So the next is the input is daily data is required for the UBC watershed model, daily or hourly. Not we cannot perform it monthly or on yearly temporal scale. And about the stations, up to 5 stations we can support. The next is, now we can also perform our some examples on the UBC watershed model. In this regard, we have shared with you the data. So we need to open the UBC watershed model software, and like we have guided one by one. Now we will do by practice.
Excuse me?
Okay. Yes.
Yeah, before going to the practice exercise, I would like to ask few questions.
Yes.
Like you have discussed here, you have divided your model into 3 sub-model. That is, sub-model 1 is the meteorological model, in which you discuss about the meteorological parameters like temperature, rainfall, and the flows. And the second one is your soil moisture parameter, and the third one is your routing parameters. But in the model 2, that is soil moisture parameters, in which you haven't discussed that how you have prepared those parameters,
Actually,
which routing techniques have you used for this?
I think one parameters. One parameters we got from the impermeable area, or areas related to the soil. So yes.
Like HMS model, they have soil moisture counting parameter techniques, in which they have multiple parameters, like what percentage of the soil is there, the groundwater share, the maximum infiltration, soil storage, and other parameter, imperviousness area.
Of course,
all those parameters.
Of course, if we open our WAD file now.
Yeah. And also, you haven't discussed about the routing techniques, which method you have opted for the.
Actually, the routing techniques are purely not. I mean to say that it's not a newly UBC watershed model that we are using. It's from the 50 years we are using. So
yes.
It is not difficult at this time. Not difficult to search on the website or published articles. So here our purpose was that is basically the physics, on the physics and or the parameters of the physics. We can also we have our plan in the webinars. We will also discuss in some webinars the physics of the these hydrological model.
So these are the by
this time,
default parameters which you have mentioned in your Watt file,
no.
or you have calculated these parameters for your watershed?
We have calculated. We have
Okay.
calculated, and so that's why in the presented slides, the results of the statistics are fine.
Quite matching. And the second thing I would like to ask is this snow melt techniques, whether it is this model is using the energy based technique or the temperature index method?
No, energy based technique here. Like if you can see my screen, that
yes, I can.
This is a equation that the model used for snow melt in MMs. Like like 3 energy contributors are given. Given the units of water equivalent. First is convective heat transfer.
I think you have taken the maximum and minimum temperature. So as I know, it's a temperature index technique rather than the energy based techniques.
We cannot say totally temperature based, because also we have also here the net radiation energy inputs and radiant energy factors. We also put in the UBC. We consider those parameters: energy factors, radiant energy factors, net radiation energy factors.
There's some of the parameters of energy techniques also being used. Okay. And the secondly, I would like to ask that as you mentioned that you can incorporate your precipitation data in daily or the hourly basis. So if I would like to add some of the satellites provides me hourly rainfall data as well, but the temperature data is usually daily based temperature data. There is maximum minimum temperature data. In that case, how I can incorporate my temperature data and hourly rainfall data in.
Yes, if you can see my screen, that here is time increment of climate data, like daily or hourly.
But in that case, like if I have 24 hours rainfall data, that after each hour I'm getting a rainfall, but the temperature data is a single value.
We need to manage that same temporal scale, those data firstly.
Okay,
for the UBC inputs, for the inputs of UBC.
Okay, but we don't have a maximum and minimum temperature values on a single value we have. Okay? But if we want to run the model in hourly basis, or we need to input the data in hourly basis for rainfall, then in that case,
you mean that we have one data in hourly and another data is, so why not we get the daily single value from the hourly available data?
Sometimes we normally run the model in real-time scenarios, like in the recent monsoon season. We are watching how much flow will be coming in the stream or the rivers at desired gauging stations. In that case, we don't want that how much rainfall will be accumulated, and then we run the model. We are watching the system on real-time base rather than that we run the model when the rainfall has gone for the last day. In that case, exact model is applicable or not?
Is not exactly. The temporal scale should be the same for one station. For one station. Yes.
Okay.
If I talk about the climatic station, for the particular climate station, temporal scale will be the same.
Okay. Secondly, please also mention that as Uttam has asked you that you can incorporate only 5 gauging station in your model. There is a limitation for that. Where is the latitude, longitude, where you can change it?
Yes. We if it's a VAT5, the first one is the area of the first row is about the. Actually, here is a routines. First is a parameter. Second is the meteorological and flow data. Third is the elevation parameter of our climatic station. The fourth is description of watershed. So we need to just update according to our catchment name or area, the how much glacier area in that latitude, what are the latitude of our climatic station, this one, and the starting date of our run, ending date of our run, like this. So one by one, not these are not, if somebody is using already hydrological model, if it's nothing for it's actually it's a problem is for the beginners. If somebody is already know about the hydrological model, it is not so big deal to tackle these type of the
Exactly.
lines or data. It's just few lines, like 100 or 200 lines, like this.
Yeah, and I would like to ask one more question, because time is very precious and you have to perform
Yes,
the practice exercise as well.
yes, yes, yes,
Because
yes.
you have mentioned in your output report that this much flow is contributed from the snow melt and this one is from the glacier melt. On what parameters the model decides that this much flow is coming from the snow and this much from the glacier melt?
Yes. It's all about the mention here, like uh, here I mentioned this one. Yeah, you can see these are the parameters, our precipitation representation factor from
Yes.
snow and rain respectively, like this.
So you have mentioned the
Yeah,
factorial
snow
values
also
for these parameters.
for sorry.
You have mentioned these factor values for these two parameters that are this
We, we,
much
we can we can
we
find
can.
we can find from the manual, or we can find from the, I also shared
Okay.
one literature here, like this, for the ranges of these parameters.
Okay. And you have mentioned like a three stages calibration.
Yes.
Would you please tell me which parameter is most sensitive
More
among all
more
these
sensitive.
parameters so that we can tune
Any
first those
I
parameters?
suggest that we should work on the these 15 parameters, and
Okay.
because we suppose that this model already run numbers of times the Himalayas, and its parameters are uh, those parameter ranges are given in the appendix of the manual. It's applicable for the also Himalaya range, but a little bit change in those 15 parameters that are here are listed. So from no need to change more and more parameters. I think we need to work only
Mr.
to get the
Bashar,
snow melt from these 15 parameters. We need to just a little bit variation.
Professor Saab,
Okay, thank you
I
so
think
much. Thank you. I think I shouldn't waste much time because the practice will be left otherwise.
yeah, we
It's
have
okay.
a limited time,
Yeah, yes.
and
Sorry.
further we can further discuss it with Dr. Mudassar in
Can
detail.
I have one question?
I think
Yes,
we
yes,
should.
please.
Yes, it's a very
Because
brief one. You talked about the calibration of the model, but if we want to validate the results of these UBC, so for that validation, does the model give any option?
Validation also, for validation for also we need to just change the our hydrological data and keeping the same with the same environment of parameters.
Okay,
We need
okay.
to repeat again one step.
So repeat again. Okay, okay,
Yeah.
okay. That's fine.
Okay, now I think now we move to the practical session of this webinar, like hands-on exercise UBC. Firstly, we need to run the UBC watershed model. Yeah, this is the user interface of the UBC watershed model. And first step is like tools. Using the tool, we need to convert our input files. From here, we have ADM file, meteorological data files, and we need to browse our located files. Here we have our climatic station meteorological data file. Just select. It will ask about information about missing data and how convert. It's an object required error. It's not a big deal to come bugs multiple times. It comes with, so I need to chart. We can upload the file from another source.
Sir, can you repeat? I think I missed some of the steps.
I think it is the first step we are doing now.
No, I guess you converted the files
no,
or not?
No, not yet.
Okay.
I think the users, if they are also using this software, they can do in their own system by following the same methodology. Just browse the provided file. Yes, like this, you can see that if we just change the path, we just change the directory, it is it cannot be run. I think this setup is some problem. We can perform this exercise from our IT in charge or handling this. So handling this webinar as our software, as ours computer software. Yeah, you have the data of Azaz?
Yes, I am.
Yes, Azaz, ready?
Are you opening the software? Please wait.
Hi, since we are waiting, maybe I can just ask a few questions then. In the initial presentation that Dr. Mudassar he did, he referred that the UBCWM model is a semi-distributed physics-based model, right? Physical model. But so far, what I have seen in the UBCWM, it's like a lumped model, but the processes, they are again like physics based, and the semi-distributed nature, if there is any, it is coming from the different band of elevations. Am I right? Hello, is anybody speaking? I cannot hear you.
Assalamu alaikum. I am Havish Shafi from University of Karachi. Can you please tell us how to set the path so that I don't need to browse time and again to find the file into the software? Hello, did you listen my question? Hello?
Still, we cannot hear you. Hello? Hello.
Okay, now Dr.
Yes,
Ashraf, you
yes.
can. Okay.
Yes, the Uttam has a question about the basis of the model. I think Uttam, you are right. It's a actually it's a conceptual model and
Yes.
lumped basis.
But I see that there is some semi-distributed nature also. Seems like within the model itself, we can specify the different elevation bands, and for each of the elevation bands, at least the precipitation station can be different. So in a way, it's semi-distributed also. But the semi-distributed
Yes.
nature of the, let's say, the hydrological units like the sub basins, they are not here.
Yes, yes, exactly.
So, so now we share or start again our practice session. Firstly, from the tools menu, we need to convert our ADM files to BDM. Choose the file from the directory UBC Watershed model. So we have provided you the UBC input folder, and here same files like this. We just need to choose our ADM files and then convert. Here we have already files, so we need to overwrite it. So like this, the first step is completed, and the second is we need to convert our discharge file.
Sir, we haven't seen this bands file, please.
Sorry?
When we open the conversion tool, we haven't seen this bands file.
Hangs?
But in the folders we have these files.
Yes, you cannot see. Maybe you can. Sometime these files goes to the virtual directory of your computer. You can locate. From go to the app data, local app data, or your programs files, and then Gmail, then UBC Watershed folder. You can locate,
okay.
or you can see, or you can copy and paste to your original where you want to keep those files. But anyway, if it is converted or you cannot see, but it's fine for the practice session, because it will upload again, guys. Okay, the next step is to convert discharge file ADQ to BDQ. Just see watershed model. actually yes, ADQ file. You just select the ADQ file and okay, convert now. Yes, yes, you can see it's done. Now the next step is to browse the WAD file. Next step is browse to WAD file from the same directory where I think you have uploaded successfully by the maximum participants.
The number you have dialed cannot be reached.
Yes. Now you can see the file panel. File panel list. We have
Participants are requested to
okay. So after uploading the WAD file, you can we can view our converted files PDM or PDQ, discharge file or PDM. If double click on of any file, you can see the results. You can see the graphic window of the input files like this. It is just for the inputs. So the next step is to run the model. In the run, firstly need to run. Actually, I think in this folder it is already run, but we can run it again. So here we need to confirm the start date and end date of the provided file. Yes, yes.
Before going ahead, would you please explain only in one sentence what does ADQ mean and what does BDQ and why we need to convert from ADQ to BDQ?
Because it's I think it's a ASCII or binary files. It does not the model does not take the firstly accept the ASCII files.
Okay, sir.
Yes, it first the binary, then it process the next steps.
Okay, so the conversion is basically to convert the data into binary
yes.
form.
Yes.
Okay. Okay.
Yes. And now after confirming the start and end date, we need to run the model, and it will. And the second is to run the statistics. After running the model, we can see we have a file lam4.pc. Yes, it is actually the output file that we have acquired from the running the Watershed model. The next step is to run the statistics. Here we need to confirm again the start and end date and make sure the check of statistics for the whole period and month, whatever you want to keep for the starting first, and if the user wants the some others files like season wise or specific season wise or for the whole period. Here I selected just for the whole period statistics file. So click OK. Here right again. Okay, it's finished. So now we can see the view. Yes. And also we can view the our statistics files from the directory. like here you can see this is also a .sta file. You can also view in the notepad. I think in this computer maybe not, but we can see it in the notepad file. Okay, edit, yes. Okay, here we need to if we see its statistic report, here we can see our coefficient of determination and coefficient of efficiency. Like need to confirm from here if it is below 0.5, or if we have a classification of our performance of our hydrological model performance, good, very good, satisfactory, like this. Okay, so the next is to view its graphical. Okay, if I like double click just output file BDC, and here we need to its chart of a cycle of 1 year. Then, but we can see the whole period of our calibration and validation by setting its configuration, chart configuration from chart menu, chart configuration. Here we need to select user defined. Number of days is shown on chart. Like we have a data of 3 years, so we need to, if we want to see the whole year, the whole period data in one window, then we need to put here maximum number of days. It's a x-axis labeling how the user want.
Can you please repeat the stats steps? How to run these?
Okay. In the end, we will repeat. Firstly, we need to complete this practice session. Then we will of course we will repeat if somebody asks any step. Okay, this is a whole period calibration or calibration of our model, hydrological model representation. The next was the step of, I think yes, of about the different type of melting from the select component from the last, and just need to check whatever the modeler want of the snow melt or glacier, they can check that box. Like this. And now we need sometime where we need this data in Excel, so we need to convert this output file to in the Excel to make a graphical representation by their own choice, or in the better software, or for the resolution, or etc. So need to tools, same it's the reverse process, input data collection tool, and here from select from same ADM ADC. Yes. We need to keep firstly as the step is same, like first we convert. Here we need to just select the files, the result file bdc.bdc, we need to just select, and it will convert to ADC. It will convert to the UTC. Yes, here we can see the ADC file that converted just now, and now we can open with a notepad and copy from here. We can convert into the Excel or any other extension where we want. So in here the description is missing in the description of headings. Column heading is missing here, but from the visual interpretation of the graphs, we can put the headings of these. We can put the headings of these columns. What type of the results they are getting from here, or it's a snow melt, groundwater, or or rainfall, etc. Like this. It's a input data. Like as according to the select component, it presents the results according to the like number of so many components here in cubics and mm per day. Whatever the users wants, they can get that type of the runoff results. So thank you very much. If you have any question, I think the users performed the participant performed this activity. If some participant face any problem, then please he or she can discuss. Okay.
I am having problems while opening the statistics file.
Statistics file. Okay.
Yes,
from the
it is
window
created in the folder, but I cannot view it in the menu bar.
Here is a problem. I think the somebody from the group can guide how the users locate their output files. I think sometimes it goes to the virtual memory, like here in this system. If you can view my screen here. ADC file was not here. It reaches to the it save is this directory virtual store program files UBC model setup like this. It's a app data local like this. So we can view our star file from here, .sta file from here.
Excuse me, sir.
Yes.
Sir, we are having a problem over here, and the problem is stating prompting like runtime error 91, and it states object variable or with block variable not set.
We can remove just now. Just go to the chart and set chart configuration, and here the steps like this: user defined, like number of days, user defined 1200, 1300, or it's a because 1200 by 1200 because otherwise around 1000. So I put here 1200. Then your problem will be solved.
I will go to chart. Sir, would you please repeat the step?
Chart configuration.
Chart configuration, yes.
Set the first value is 1200 user defined.
Okay, sir.
And 1200 or 1000, 1100.
This might be any number.
Yeah, no, not any number, because we have data of 3 years.
Okay, sir. So
the 3 years days equal to 3 years.
Exactly. Okay, sir. Got it.
Right.
Chart configuration.
Yes. Okay. Any other facing any problem? He can discuss any time in the group, or about the physics, about the literature, about the parameters. Till we will discuss if any problem or any question related to the first part of this hydrological modeling for snow-fed catchment webinar, or second part, please share you please share the in the group. We will provide you feedback according to our best knowledge. All right. Thank you very much. So just
Okay, after this webinar now, we will share the recordings of it and all the relevant data, including the presentations, user manuals or the data sets, and also the source codes of the R language. And also we will share there are some questions about the R language which couldn't be answered, and we will also share the contact details of Mr. Uttam, and he also shared 2 papers of him, and we will share these all things in the group or by email. And if anyone have any questions, they are welcome. Or we will, and one more thing about the certificates, and the participants who participated from Pakistan, we will post them the certificates at their respective addresses, and for foreigners we have limitations that we can only share them the e-certificates. Now I think if there is no questions, I invite Professor Dr. Noor Muhammad Khan to give his concluding remarks. Please, sir. Dr. Noor Saab, if he is listening. Okay, I think I should remind him.
All right, the participants can also share their.
Excuse me?
All right, we need
Yeah,
to a little way the confirmation about the closing remarks from the Director, Center of Excellence in Water Resource Engineering. So if anybody about the model have any questions, then please.
I would like to ask a question from Dr. Mudassir. I think his name is Mudassir, who taught about the model.
How many participants successfully run this model?
Assalamu alaikum again. Sorry, I was a little bit away due to office business. I have been informed that the session, practical learning session, has been completed. Is it so, Dr. Mudassir?
And will provide the.
I was part of the session 15 minutes ago, and he was converting the files, and he was showing the statistical method, the statistical outputs.
Yes,
Dr.
sir.
Mudassir,
Will you ask
mic
anything?
Dr. Ijaz, are you getting my voice? I am seeing in the participant Mubashir from.
Yes, sir. Yes, I would like to ask a question from Dr. Mudassir.
And I was listening some foreign accent also. Okay.
Yes, yes, please.
Okay. At the end of the session, let me thank you all the participants, for sparing time and joining this effort, joining this webinar. Hopefully, all the questions have been answered. If still there are some questions, you are welcome to send it through communication media. Hopefully, Mudassir, Ashraf, and our other colleagues will be answering it. Ijaz, can you finish the echo? Some of the speaker over there in the room should be closed, should be muted. Echo is there.
I think
And
now is fine, sir.
okay, yeah, now it is fine. Uh, I would like to congratulate both the speakers and the organizer. And still, I am available. If you have any questions, we can discuss it for a couple of minutes. If any question is unanswered, maybe my other colleagues will be able to answer. Or if you suggest, we can have a longer session, more practical nature session can be arranged for this.
Yes, sir, definitely, because the some of the parameter like the soil moisture parameter and the routing techniques and the parameters that they haven't mentioned in their slides. So I think that they need more emphasis on that as well, because how to prepare those parameters for the model.
Yeah, maybe that's good suggestion, Mubashir. And
yes,
ask Mudassar to maybe arrange 1 hour or 2 hour practical session for improving the calibration by changing different calibration factor. I was seeing that he told that these 15 parameters are more prominent. These 15 parameters are more effective and have more relationship with changing. But if he can tell us that if we change permeability, how the shape of the hydrograph will change, if we change the storage coefficient, how much, what will be the effect on the lag time, and so such things.
Yes,
so that can be a more elaborate example. And Mudassar, can you arrange a 1 hour more detailed
Yes, sir.
seminar?
Why not?
Webinar?
It's a
Okay.
complete 100 parameter story in the UBC watershed
I will
model.
say 100 parameters, maybe some of them are very minute parameters and their standard value can be chosen. But
Yes,
more
yes.
parameters which are related to our physical nature of the soil, physical nature of
Physiographic,
that
yeah.
area.
Yes.
So,
Yes, physiographic parameters.
somebody from abroad was also asking if I can help something. Anybody from abroad?
Mr. Uttam.
Yes, sir. Yes, sir. Can you hear me?
Yeah, I am hearing you. Yeah.
Yes, sir. So there were a few comments from the guest, and they were quite interested in the different kind of bias correction techniques that may be employed with R. So I had some work done previously on the same, and I'm willing to help if somebody needs any help, any guidance on that one. I have some scripts and some sample
nice.
exercises also. So I can share it with all of you so that you can use it in your data presentations also. Yeah. So
That's nice.
Yeah.
That's very good. One of the purpose of such webinar and seminar is to group together the people of the same interest, same mind. So through this list of these people who are interested in the modeling, hydrological modeling, especially the snow-fed and glacier-fed reaches, they can even interact with each other. So that is an additional benefit of such seminar, that a group is created and then they can further tie up the links and enhance their linkages and carry out the combined research together.
Definitely, Dr. Noni. Yeah.
That's good. Okay, I think now I formally conclude this session. Thank you very much, Dr. Ashraf and Dr. Mudassar and Dr. Ijaz and all the participants, Irrigation Department, WAPDA, Federal Flood Commission, and all various universities. I was listening to a lady from Karachi. Thanks for your joining over here. And hope to see you in seminars in future, also in webinars and seminars. Thank you very much.
Excuse me, sir. Excuse me, sir.
Yes, please. Yes, please.
I would like to request Mr. Uthman, I don't remember exactly his name, but the one who was talking just before me. I'm keenly interested in bias correction techniques because I'm working on climate change impact assessment using SWOT model and in combination with other like UBC watershed model. And for that I need as previously I did work on quantile delta mapping techniques and some already generated sheets. And this is what I was searching for, that how could I use R language or R package for bias correction techniques. So that would be so kind of him if he could contact me, or he could share the reports or whatever he was talking about. That would be so kind of you, and I would be highly glad to know all these in detail. Thank you so much.
I think he has listened it. Please.
Yeah, definitely, Muba sir. You can actually email me also. Actually, some of the participants, they have already started emailing me. So you can also email me, and I will also communicate with CEWRE, and I will send them the paper that I wrote, the sample scripts that I have, the sample files that work directly with that script, and do like different kind of bias correction techniques. At least 8 or 9 different techniques are there. So all of them, they are already integrated in the script. So definitely I will share it with you, and yeah, please feel free to modify it, but with of course proper reference and everything. Please feel free to modify or use it for your research. Yeah.
Thank you very much.
Okay, sir. Okay, sir. Thank you so much. And sir,
contact with Uttam.
And sir, in last, I would also thank you for providing such an opportunity and such a very good platform to meet all the all professionals and mid-career students. Thank you so much for arranging such a great opportunity and such a great workshop.
Thank you very much
So
for
nice.
joining. Thank you
Thank
very
you.
much.
Thank you.
Okay. I am leaving now. Thank you. Allah Hafiz.
Thank you, everyone. Bye bye.
Okay, thank you. Thank you, everyone. We will share the data and all the exercises, models, or the source codes, presentations, and the videos. So I think now we can officially leave it if no one.
Excuse me, sir. Excuse me, sir. I have one last. Sir, would you have any kind of certification or in writing something for this
Yes,
webinar?
yes. I have already mentioned that the participants from Pakistan, we will post the certificates on their respective addresses.
Okay.
And
but sir,
the participants from
we are
abroad, we can
okay.
only share them the e-certificates.
Okay, sir, but we are not yet asked for mailing addresses. We didn't
We will
provide.
ask you your postal addresses.
Okay, sir. Okay, sir. So nice of you. Thank you.
Thank you, sir. Thank you very much. Okay. Very much.
Assalamu alaikum, sir. Assalamu alaikum, sir. Hello. Dr. Mudassir Saab, can you hear me?